Within a month of releasing its first sharp image, scientists and researchers recognize how far the James Webb Space Telescope can push the laws of physics. According to NASA officials, the image indicates that the telescope's 18 individual mirrors are now perfectly aligned and operating as one, and the shot is much better than scientists had hoped for. The Webb team released a photograph of the Milky Way star designated 2 Mass and located roughly 2,000 light-years away. It was taken with a red filter to maximize the visual contrast between the star and the blackness of space, while dozens of other stars and distant galaxies can be seen in the background. Webb engineer Lee Feinberg Siad, you not only see the star and the spikes from the diffraction of the star, but you see other stars in the field that are tightly focused, just like we expect, and all sorts of other interesting structures in the background. We've actually done a very detailed analysis of the images we're getting, and so far, what we're finding is that the performance is as good as if not better than our most optimistic prediction. Grant Tremblay, an astrophysicist at Harvard University, tweeted, "Here's more info on the James Webb field. I can only identify one galaxy at Z0.285. The rest don't have spectroscopic redshifts. Deepest optical image I can find is Pan-STASS. The Milky Way star distance is 1,995 light-years from Gaia Space Observatory." Spectroscopy is the study of the absorption and emission of light and other radiation by matter, while spectroscopic redshifts are often derived by cross-correlating a library of galaxy templates with observed or simulated spectra. This image is more than just confirming that the telescope is operating smoothly, it's also a clear demonstration of James Webb's capabilities. James Webb carries 4 scientific instruments on board, but only one of them, the near-infrared camera, helped to deliver this first image. NASA believes the remaining 3 will be in action and ready to begin the scientific imaging process in June or July. In the background of the stunning bright star image, galaxies and clusters of galaxies that hint at what Webb will show us once fully online. Hannah Wakeford, an ExoPlanet scientist from the University of Bristol, said on Twitter, "Look at some of those galaxy clusters in the background. This telescope is going to amaze us at every step. And with a point of light, we can measure the atmospheres of otherwise invisible planets. This is in part possible due to its unique optical system and design, which required it to be folded for launch and gradually unfolded over a month. While some of the largest ground-based telescopes on Earth use segmented primary mirrors, Webb is the first telescope in space to use such a design. Being able to detect faint infrared light will allow astronomers to use Webb to peer deeper into the early universe or detect faint atmospheres on distant worlds. In addition to enabling the incredible science that Webb will achieve, the teams that designed, built, tested, launched, and now operate this observatory have pioneered a new way to build new space telescopes. The key lesson learned from Hubble is that there is an exciting science that one cannot plan for, the unknown unknowns. The explosive developments in ExoPlanet science have influenced the design of the instruments that are now on board JWST. Thanks for watching.